Okay, a quick corollary, it's really easy to prove, to the mean value theorem is Rolle's theorem. And Rolle's theorem says if you've got yourself a function that's continuous on some closed interval and differentiable over the open interval, so you don't care what happens at the endpoints for the derivative, and if your function starts and ends at the same place, if your two y values on your endpoints are the same, then there's got to be some place in that interval where the derivative equals 0. It might happen more than once, doesn't tell you where it happens, but there's got to be some place in there with a horizontal tangent line. Okay, so let's draw a picture. What this is saying is I've got some function so that it starts and ends at the same height. F of A is the same as F of B. It's this value here. Now, what we're saying is no matter how much your function wiggles, as long as it's a continuous differentiable function, in order to get from this point to that point, it might do something like this. It might go up like that. No matter what it does, there has to be some spot where it turns around and has a horizontal tangent line. There might be multiple ones. It might be at a minimum. It might be at a maximum. There's got to be at least one. What this will mean later is every function that starts and ends at the same place reaches a maximum or a minimum someplace in that interval, has a local max or min someplace in the interval. And that will help us later with something called the extreme value theorem.